Hello everyone. Can you hear
Good
me?
morning.
Can you hear me?
Yes, yes, sir.
Everyone can hear me, no? Is there any problem?
Yes, sir. Yes.
Okay, everyone joined. Only 15 students are here. Join fast. Okay, let's get started. Okay, what was our last class? We have discussed about the displacement and distance and displacement. Everyone understood, no? What is displacement and what is this distance? What is the basic difference between displacement and distance?
Yes, yes, sir.
Okay, everyone understood, no?
Yes, sir.
Okay, uh,
Yes, sir.
okay. Now we have done some numericals also for this. Okay, okay. Next, we'll today study about the Newton's law. Okay, there are three laws, okay, of Newton. First law, second law, and third law. All are related to motion. Okay, what does the first law states? First law of motion: a body at rest remain at rest, or if in motion remains in motion at constant velocity unless acted on by a net external force. That means that means suppose if a ball is moving, the ball wants to move in the same speed, same velocity. Okay, if a ball is at rest, the ball wants to be at rest. Understood? That means if we apply a force, or if we uh, apply a force on that particular object, then only it will move. Okay, after applying a force, the ball wants to move on that particular speed or on that particular velocity for entire time. The ball doesn't want to stop. Okay, but in practical cases it will stop because of the resistance of the air, resistance of the uh, wherever it is traveling, the medium, resistance of that medium. Okay, it will stop. That is the first law. Example, if you kick a ball in space means, what do you mean by space? What do you understand by space? Up in the world. Okay, it it would keep going forever because there is no gravity, friction, or air resistance going against it. It will only stop going in one direction. Understood? In a space, if you kick a ball, it will move like for entire time. Okay, entire lifetime it will move. Understood? Because there is no medium, there is no resistance, there is no gravity. Okay, understood the first law?
Yes, sir.
Okay, the second law. Second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. That means we can say F equal to net force. That means F, we will denote it as F. F equal to ma. That means mass, m for mass, m for mass, a for acceleration. Mass into acceleration. The net force acting upon the object and the mass of the object. Okay, F equal to ma. That will be the formula for the second law. Understood? Example, if you use the same force to push a truck and push a car, the car will have more acceleration than the truck because the car has less mass. Okay, see, if you have some, you are applying a force on a truck and on a car, small car. Okay, which one will go faster, or which one will have acceleration? The small car will have the acceleration. Okay, because the mass is lower. Understood? Third law. It is the most interesting law. See, states that for every action, that means force. Okay, it is telling about a force. In nature, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts a equal and opposite force on the object A. Let me explain. Suppose you are pushing a wall, okay? The wall also pushes you with the same force. Understood? Have you ever tried firing gunfire? Anybody? किसी ने गन फायर किया है?
Yes, sir.
हाँ?
Yes, sir.
Yes.
No.
गन फायर किया है तुम लोगों ने?
No, sir.
Karmun Tadar. Is it now clear, voice? Your network is... Check your network. Okay, have you ever seen firing a gun? Somebody firing a gun?
Yes, sir.
Where?
No, sir. No.
तुम कहीं पे भी गन फायर नहीं देखा फिल्म वगैरह?
नहीं, मैं रियल का सोच रहा था.
अच्छा, whatever. Have you seen in movies or somewhere else?
Yeah, yeah.
No.
Yes, yes.
Okay. In real
Yes.
life, you have not seen.
I see, man. No, but I have touched the bullets and different types of guns I have touched.
Different types of gun you have.
I have touched in real life and bullets also.
Acha, acha. You have touched.
Yeah, yeah. When I used to study in college, that time means exhibition is there, not then army, the real army used to come and make an exhibition of guns
Okay, okay, okay,
and
okay.
bullets.
Okay, okay. Then, have you seen them to fire when they have fired? No.
No, no,
Okay,
no.
okay.
Just
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 for
the show.
exhibition.
Okay, exhibition. Okay,
Yeah, that's all.
understood. In films or in some video, have you seen someone firing?
Yeah,
Okay, just remember one thing: when he triggered a gun, okay, his arms also like gets jerking. Have you noticed? When he fires,
yeah, yeah, yeah.
his arms also get jerked.
Yes, sir. It's
Okay,
certain.
have you seen the rifle?
Yeah,
Okay, rifles are used to hold here in the arms. then he trigger, then he fires. Uh, they usually mm, hold their rifle in their arms. That means attached with their arms. Then he fires because there are lots of recoil velocity. Okay, leave the recoil velocity. You will not understand now. But thing is, if the gun is firing, okay, with lots of speed, the bullet exits, right? With the same velocity, the gun also hit the man. Understood now?
Yes, sir.
Everyone understood now?
Because of because of force.
Because of force, that means the gun is applying force on the bullet. The bullet also applied
Yeah,
opposite force to the gun. Okay, and gun
yeah,
will hit you in the arm. That will give a jerk. Okay, that is the third law. That means each and every action has equal and opposite reaction. That means if you punch in a wall, okay, if you punch in a wall, the wall also hit you in the with the same force. Understood? But you can now say like,
I,
sir,
yes,
I have punched my friend's arm, but he should also um, hit me like with the same force with his arm. Yes, exactly. If you hit somebody, his arm. Suppose if you hit somebody in his arm also apply equal and opposite force with the same amount of force. Okay, on you. But thing is, that force will hit on your arms. That's why you will not get hurt. Understood?
yes, sir.
Okay. If not, then tell me. I will explain it Hindi or some other language also. Sorry, I don't know other languages. Only Hindi and English and Assamese. Should I explain it in Hindi?
No, it's okay.
It's okay. Understood properly.
Yes, sir. Yes, sir.
Okay. Next. See, the example of the third law. Okay, when you jump off a small rowing boat into a water, you will push yourself forward towards the water. The same force you use to push forward will make the boat move backward. That means, see, have you ever been in a boat, small boat?
Yes, sir.
Have you ever been a small boat?
Yes, sir. Yes, yes.
Okay, try this one. Go to the boat and make yourself jump towards the water. Okay, if you jump
Yeah.
from the rowing boat or the small boat, you will go up forward, the boat will go backside.
Yes, sir.
Okay, now there are two more terms. Okay, let us study now. Angular velocity and angular acceleration. See, have you understood the velocity? What was the velocity? I have defined, no? What is velocity?
External force, sir.
No. See, this one is velocity. Okay. Velocity of an object is rate of change of position with respect to frame of reference. Rate of change of position. Okay. And this one is acceleration. Is the rate of change of velocity of an object with respect to time. This one is acceleration and this one is velocity. Understood? I have already explained it. See, now the same term here. Angular velocity and angular acceleration. Both are same. Okay, both are, that means velocity and angular velocity are same, but thing is angular velocity for circular motion. It is for circular path. See, understood? Both are same. Velocity and angular velocity are same, but angular velocity considered in circular path. A little bit difference are there, but right now you don't need it. Just remember this: angular velocity will be calculated in circular path, and velocity is in normal cases like linear and all. Angular acceleration is also the same with acceleration. That means a minor difference is there, but leave it. Angular acceleration is the same with the acceleration. Acceleration means the linear, in the linear one. Okay. Done, everyone? Understood? Hello, everyone. Hello, you can hear me now? Hello, 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 hello.
Yes, sir.
Okay, okay, okay. Do one thing. I'll upload the class. Okay, I'll upload the class. Done. Okay. See you in the next class.